Welcome to today's session on scene layers and developers. My name is Yvonne Seeler. I'm the product owner of the scene layers team. We are a functional team covering all aspects of scene layers from creation to client consumption, such as ArcGIS Pro. I'm working in software development a little bit more than 10 years, and originally I came from Esri, Germany. Our team knows how important it is to our customers to enable developers to build applications. We are adding more staff to our team to work on Pro and Esri SDK, Esri specification, and additional tooling. With me here is Monika Nientiet. Monika is working as a developer on the Scene Layers team and worked primarily on the Pro SDK. Before we dive into the details, I would like to share our vision statement with you. We are using this for our internal presentations, as well as to make sure functionality we work on align with our vision of what scene layers need to provide. I'm not reading this in details to you. You can pause the video. The scene layer lifecycle is defined in 4 areas. You can author a scene layer in one of the ArcGIS clients or by third-party vendors. You can publish content to share across the platform. You can consume it in clients such as Pro, Runtime, ArcGIS Earth, or Scene Viewer. You can maintain scene layers by replacing the service. This will be available in Enterprise 10.8.1, or by editing scene layers with associated feature layer in ArcGIS Pro, then rebuild the cache for the scene layer. Let's take a look at the different areas in more details. Currently, you can create a scene layer from the following input type. For point cloud scene layers, you can share a last dataset layer. All symbology and properties you have defined will be honored. You can also directly input last Z or ZLAS into the SLPK tool. Point cloud support 32-bit, allowing you to create very large point cloud scene layers. Integrated mesh are often created by third-party vendors, but you can also use the Create Integrated Mesh Scene Layer package tool to create an integrated mesh scene layer from OSGB. You can create a scene layer from multi-patch as 3D object scene layer or point feature class as point scene layer. Depending on the way you share them, as a scene layer, you can create a scene layer with an associated feature layer. This gives you additional capabilities like editing or search on the web viewer. The latest layer type we introduced was the building scene layer created from a building layer. Building layer allow you to visualize 3D building information in ArcGIS. And with the building scene layer, you can share this information across the ArcGIS platform. Right now, you can create an SLPK, but we are also working on support of associated feature layers to be available in Enterprise 10.8.1 and ArcGIS Pro 2.6. This would allow you to maintain and update attributes of assets or search for assets, for example. After you have prepared your scene layer that you would like to share with your customers across the ArcGIS platform, you have 3 options on how to share the scene layer. You can share within the web scene. If the scene contains one of the layer types, you can share as a scene layer. The scene is always shared by value. The data are copied to ArcGIS Enterprise or ArcGIS Online. For feature-based scene layers, such as 3D objects or point scene layers, an associated feature layer is created. The coordinate system of the scene layer is identical with the web scene that you publish. You can change the properties of the scene layer. For example, you can make it editable. If you share an existing SLPK, it will be uploaded and published. You can share it as a web scene layer. You can define to share as by value or by reference. In the by reference case, your data remain in your enterprise geodatabase or are read-only in a file geodatabase. Also, in this case, you can define editability for the associated feature layer and maintain the scene layer. The coordinate system in this case is the same as the coordinate system of the scene from which you publish. When adding it to an existing web scene, the coordinate system needs to match. In Pro, you can always reproject the data on the fly, but that always comes with a price tag. Your layer may draw slower. In case you plan to edit the data, we always recommend to do this in the layer's coordinate system. The third way of publishing is to create an SLPK. You have a tool specific for each scene layer type. Besides creating SLPKs, you can also validate existing SLPKs to find out if there is any issue with it. This can be useful if you get an SLPK from a third-party vendor and it's not drawing or there's any other issue with it. You can send it back with this information to the third-party vendor or send it to us so we can take a look. We improved the way you can work with scene layers in geoprocessing. Now you can create a scene layer and an SLPK using the model builder, for example. After you created an SLPK, you can upload and publish it. In this case, the scene layer is cached on the client and no associated feature layer is created. In some cases, it might be useful to actually consume the SLPK directly in ArcGIS Pro because the performance is very good. As I already mentioned, our team is working on Esri as well as on Pro as a client. Therefore, I'd like to show you some example on how scene layers are consumed in ArcGIS Pro. I'm sure you will have many examples on how they are consumed in JavaScript API or runtime. With point clouds, I can visualize LiDAR data with billions of points. This layer type is supported in all ArcGIS clients. Already in Pro 2.3.10.6, we optimized the layer for dense interior and exterior point clouds. When consuming a point cloud scene layer, you can make changes to it. In its appearance, for example, change in the symbology or filter. I have here an example for an interior point cloud created by Trimble at one of the user conferences in San Diego. Some of you might recognize the conference center here. When I go inside of the building and turn on the point cloud, I can see the interior and navigate within the showcase islands. That was done while people were visiting, so sometimes you can even make out individual people. When looking from above, you can actually recognize many details. Integrated mesh scene layer types are mainly provided by third-party vendors. Integrated mesh scene layers allow to capture all 3D information in one layer. Currently, we can visualize this layer, but we are aware there are many more use cases that our customer asks for. In 2.6 and ArcGIS Online, the integrated mesh scene layer will supersede the ground and base map. That means, for example, if you have a line, a polygon, or a point that is draped on the ground, it will also be draped on the integrated mesh. This allows you to show this data together with the integrated mesh and, for example, click on Identify to get pop-up information for a road that you put on top of the integrated mesh as a line feature, for example. We are also finishing up functionality to modify an integrated mesh scene layer. For example, you can clip or mask based on a polygon, or you can even replace parts of the integrated mesh using a polygon. In Pro 2.3, we made it possible for you to create a building scene layer. 3D building information are structured into disciplines such as architectural, structural, or piping, and in category layers such as walls, windows, or pipes. With a building scene layer, you can quickly toggle on and off categories, but also apply filters to find assets within your building quickly across the whole building. I have here a fictional building, and I'm creating a filter that would only show the second floor and the outer walls as reference where the second floor in this building is. So I select the full model and I create a filter. I set a filter block with the solid mode and select the second floor, and immediately I can see all the assets of the second floor across my category layer. Now I want, in addition, to show the walls. They are in the filter type family. There are lots, so I need to search. I can now see the outer wall in addition. So I can easily just, with a couple of clicks, create a complex query and visualize it by combining different drawing modes. The order of the drawing modes are important. The filter block on the top gets priority. For example, right now, the inner walls, even though they are part of the family basic walls, draw as solid. If I change the second filter block to be on top, the inner wall will be in wireframe because the filter block has priority. One of the feature-based scene layer types we currently support are point scene layers. You can consume them in all ArcGIS clients. You can change the symbology. If shared as a scene layer with associated feature layer, you can also make edits, for example. Point scene layers are used mainly if you want to visualize millions of points, such as trees, like in this image. 3D object scene layers allow you to visualize millions of 3D objects in combination with an associated feature layer. You can work with them the same way as you work with multi-patch feature classes. You can consume scene layers in ArcGIS Pro, Runtime, and JavaScript. You can change the appearance of the layer, such as symbology. You can hide features. You can use definition queries, and many more. In this small video, I show you the data of the city of Lyon. I added noise level data to the building to visualize the noise in decibel. I'm just setting a graduated color. I change the color scheme. In this, it changes right away. I can still navigate the scene. These are about 40,000 buildings, I believe. And we have made large improvements to the scene layer with associated feature layer regarding the textures. Currently, you can maintain feature-based scene layers if they have an associated feature layer, and editing is enabled. You can share by reference, where you keep the associated feature layer in your enterprise geodatabase, or by value, and you make a copy of the associated feature layer. You need to set the editing option on the associated feature layer, and you need to make sure that the option set the Z to 0 is disabled. This is all you really have to do. Now users with editing rights can edit the scene layer in ArcGIS Pro. For us, it was very important that all the editing workflows you already have for editing feature layers remain the same for editing scene layers. As user, you don't see any difference if you edit a scene layer or a feature layer. The only difference is that users that consume the scene layer without editing rights will not be able to see your changes until you have recreated the scene layer cache as a full or partial update. For example, if you have a scene layer representing the outer shell of all the buildings in your city and you make updates to the scene layer and rebuild the cache, the moment you rebuild the cache, your changes are visible for your users. After this overview, we would like to talk about the Esri specification and SDKs. Esri stands for Index 3D Scene Layer and is the data source for scene layers. We frequently make updates to the specification, which contains the implementation details. Esri is a specification for streaming and distributing geospatial 3D content. The community standard is a process for approving widely adopted specs and formats. This is a team effort by Esri partners, customers, and other interested industry parties. We already have many vendors that actually are creating Esri. Within this OGC process, we have now also added point clouds as part of the community standard. Now moving on to the specification itself. The spec has widely been overhauled. We have rewritten the READMEs, format documents, and other details to make the spec more readable and intuitive. One of the biggest changes is that the spec is now organized in profile types. The profile types are what clients display as scene layers. If you're interested specifically in 3D objects or integrated mesh, you can find all the related materials in one place. The last spec update included documentation for point cloud scene layers and building scene layers. Point cloud scene layers are now part of the OGC Community Standard. You can find an overview of the relationship between the Esri community specification and the OGC Community Standard in the README document. We are also providing an upgrading tool to help you transition to new spec versions. We have also added more SLPKs and service examples for each scene layer type. Moving on to the Esri tooling, the Esri converter. This tool will help you to keep SLPK data up to date within the spec. As we previously demonstrated, new versions of the spec include optimizations and features that you won't be able to take advantage of if you don't upgrade. This will also validate your Esri JSON output schema. This tool does not have any dependencies on ArcGIS, and this is just the first step for us. We are planning to expand the functionality quite a bit and allow you to validate, optimize, and inspect Esri data. We are also working currently on an Esri SDK. This SDK should allow developers to write and read Esri. We are planning to make it open source. The SDK will be available for Windows and Linux. It will be native C++ in the first release cycles. We also will first have a writer of the newest version of Esri. It's 1.7 that we are targeting. You will be able to create integrated mesh scene layers. This is the first scene layer type that we will be focusing on. Your content already has to be in LOD. And we will provide you tutorials with sample data. Our goal is to have this available by April 2020 as an alpha. You will have to define the properties such as the SLPK paths, descriptions, layer types. Of course, only for integrated mesh, this will be available. The coordinate system and the normal reference frame. The properties are the input to the layer writer. Beside the properties, the layer writer also needs the mesh input such as vertices, count, vertex, texture coordinates, and textures. We have a method where you can create the textures from an image, for example. The nodes are created from an existing node hierarchy. I already mentioned that you have to bring your data already in LOD. The layer writer then saves this content as an SLPK. As I said, this is the min chip that we want to make available as the first version of the Esri SDK. But of course, we will not stop there. We have plans to add more functionality over time. One of the SDKs that we already have released is the Pro SDK for scene layers. Monica, who is actively working on this functionality, will now give you more details about the Pro SDK.
Thanks, Yvonne. Okay, so now let's take a look at the scene layer ArcGIS Pro SDK in more detail. In general, the Pro SDK allows you to create custom add-ins and automate your workflows. Here we see an overview of the scene layer structure within the Pro SDK. In the middle, we see our main scene layer types. That is the building scene layer, the point cloud scene layer, the feature scene layer, and the integrated mesh. The feature scene layer can be of type point, which means it was created from point data, or of type 3D object. if it was created from multi-patch data. In the right-hand corner, we see the iScene service layer info interface. This interface is implemented by all scene layer types. It can be used to query basic properties like the data source type to see whether it is a service or SLPK-based scene layer. We were aiming to provide basic functionality, for example, setting a definition query, searching, or selecting features. All of these you can do with regular feature layers as well. In addition to that, we are providing some more specific functionality for select scene layer types. The building scene layer is exposing a filter, which can be used to show only certain parts of the building. This is very useful if you want to show interior features only or focus on a specific floor. You can use the SDK to write an add-in which sets up a filter on your building scene layer. Then you can share this with your customers or coworkers. If you're familiar with the point cloud scene layer in Pro, you know that you can set up a filter as well and show only points that meet your criteria. The SDK is exposing this functionality as well. Now I'm going to show two examples to demonstrate the use of the Scene Layers SDK. Here's a scene layer with some of the buildings in downtown San Francisco. Let's say I have shared this with one of my customers, but I only want them to look at the buildings that have ports. Instead of creating a separate scene layer with just these buildings, I can apply a definition query and then select the buildings I want the customer to focus on. This may seem like a simple workflow to someone who is familiar with ArcGIS, but not all customers are comfortable using definition queries. I can ensure that my customer and I are on the same page by creating an add-in that will complete this workflow with one click. I highlighted the buildings we want to look at here. If you have done SDK work in the past, this should look familiar. First, we can use the map to find our layer by name. For this example, I know it will be a feature scene layer, and it's going to be the first layer in my list. You probably want to make this a little bit more robust in your code. Next, we can simply define and set the definition query. Finally, I can use the same query string to create the parameters for the selection statement. Okay. Now let's run the add-in. This can all be done in Pro 2.4. It's a great way to work with large data sets, like city models, for example. Here's a more complex example that shows the editing capabilities for scene layers. We want to update the building name and include today's date and time. This could be used to update any editable attribute in a scene layer, not just the name. This example demonstrates how we can use features from other parts of the SDK with scene layers as well. We create the query filter as we did in the previous example. In order to update the building name, we need to access functions in the editing SDK with a tool called Inspector. This is all documented as part of the editing SDK. Next, we can update the name. We use an edit operation to modify our features. This means that if you are already familiar with using the editing SDK, we also know how to edit scene layers. Before I run the next video, I'm going to quickly explain what it does. First, the service is opened in ArcGIS Online, and we can see the pop-up data. Then we go back to Pro and view the same pop-up details. Next, we run the add-in we created and verify that the data has changed. Then we refresh ArcGIS Online and see the changes in the pop-up. The pop-up information is pulled from the associated feature layer, so we will be able to see the updates in ArcGIS Online immediately. If you were to modify geometries instead of attributes, you would need to recreate the cache in order to show the changes. So here we look at the pop-up data in Online. We see in Pro it has the same name. Now we run the add-in to update the attributes. We can see that the name has been updated. Going back to ArcGIS Online, we refresh the web scene. And then open up the pop-up. And we see that the attribute as well has been updated. So what's next? Everything we have shown today is what we are currently working on. The next i3s spec version is 1.7. We would love to get feedback on the ESRI GitHub repo. The i3s release aligns with the ArcGIS release, which is usually twice per year. This is just the first step. We plan to eventually develop a much broader i3s specific SDK that will be part of our existing Git offerings. For the Scene Layers SDK, both examples were created using the Pro 2.4 SDK. We would love to get some feedback on the SDK and what you would like to see in the future. We are currently planning on adding the new voxel layer, as well as provide functionality for building scene layers backed by an associated feature layer. And this is all we have for you today. Thank you for watching this presentation about scene layers. We hope this was informative to you.